In Chapter 8.6, we're going to extend our exploration into series that have mixed signs. We're going to learn a new test of convergence for this type of series. As you recall, most of the tests that we worked with in the prior section dealt with positive terms. So you couldn't use the ratio test, the root test, or the comparison test, or the integral test unless the terms of the series were positive. And now we're expanding our understanding and our work with series to an alternating series, and that's when your sign strictly alternates using a factor of either -1 to the k plus 1 or -1 to the k. So here's the general form that you will find an alternating series in, and we'll look at many examples. So I want to start by looking at something that looks like the harmonic series, but it has an alternating term. This term in the numerator makes it an alternating harmonic series. Let me write that down. So it's an alternating harmonic series. And hopefully everybody recalls that a harmonic series is a divergent series. So let me write that. We know that the harmonic series is divergent. My goodness here. So the question becomes, what does adding the alternating sign do to the harmonic series? So to really answer this question, we would need to explore the sequence of partial sums. And I'm going to pause here and bring in one of my slides from the PowerPoint. Okay, so I have the slide that I'm interested in here. We're going to look at the alternating harmonic series. And again, we need to explore the sequence of the partial sums to see what's going on. And it appears to converge to a limit. So unlike the harmonic series where we had positive terms, the partial sums were increasing, right? And here with the harmonic, you can see that Sn is not increasing. It's actually oscillating. So when you look at the graph, grab a pen here. When you look at the graph, you can see this oscillation going on, and it's bouncing above positive and negative above a value, and it looks and it appears that it is converging. So this is an interesting find. So I guess we need a new test. And that's what we're really after. We need to look at a new test for alternating series. And the new test is really something that we've been working with, but we have to be careful. It's called the alternating series test, and what we're going to do is we're going to have to satisfy two things. The first is the terms of the sequence have to be non-increasing in magnitude. So this thing is a decreasing series, all right, in magnitude. Magnitude meaning absolute value, right? So it has to be a decreasing series. The next thing that needs to be satisfied is that the limit of the AK term, so we're going to drop the alternating sign and we're going to look at the limit. So we're going to drop this, and we're just going to look at the limit of the AK term. And this is often confused by students with the divergence test, so be careful. This is only used for an alternating series. If the limit of the AK term equals 0, and this is where the confusion often comes in, it is said to converge. So this is very different from the divergence test. Okay, so make sure you keep them apart. And for the series with a positive term, when we were looking at divergence, the limit equaling 0 did not imply convergence. But for alternate series with non-increasing terms, when the limit of the AK term equals 0, then you have convergence. And I'm looking for my last slide here. Yep, it's down below. So having establishes alternating series test, we can use it to actually test the alternating harmonic and see what happens. So the limit as k goes to infinity. We're going to drop the alternating sign and we're just going to look at the AK term. That's clearly equal to 0. So therefore, the alternating harmonic converges by the alternating series test. And I often will write shorthand notation for alternating series test as this, by the alternating series test. Oh. So, having said that, we're going to look at an example at this point, and then that'll complete the flip portion of the classroom. And I'm going to do one. It's going to get repeated tomorrow in class by Mrs. Waite, hopefully if you guys get that far, but I would like to keep it on video as well, so we have it. I'm going to pause here and pick it up. So here's an example of an alternating series, and we need to show that the terms decrease. And they do, because the denominator is bigger than the numerator, so the terms decrease. The next thing we need to do is look at the limit, and the limit is k goes to infinity of the AKs, so you're dropping the sign and you're just looking at the AK series. And you take the limit. You can either do L'Hopital's rule twice, divide through by the highest power, or just recognize, I'll divide through by the highest power, that the powers are the same in the numerator and the denominator, so you take the ratio of the coefficients, which is 1. So, since the limit of the AK terms is 1 and it's not equal to 0, this series diverges by the alternating series test. So the series diverges by the alternating series test because the limit does not equal 0. Okay, so that's an example of the alternating series test, and we'll do some more problems.